Howdy, my name's Chris, and I'm part of the Fighting Texas A class of 2024, and I'm in deep, as my shirt says. Today I'm going to be talking about my project, the see-through model engine. So as we can see, this is a model engine, and we've replaced the cylinder well with transparent resin. You might think, well, hey, that looks pretty cool, but why do we care? But we care because this engine runs on the exact same principles as the engine inside of your car. Those principles are called the Otto cycle. The Otto cycle consists of four main steps. We have intake, compression, power, and exhaust. On the intake step, our piston comes down and draws in air and fuel into our engine. On the compression step, that piston comes back up and squeezes the air-fuel mixture as much as it can. After that, our spark plug goes off and we have our power stroke. The piston comes flying back down and delivers the power that our engine makes. Finally, our piston comes back up and pushes back out the exhaust gases that we made from our power stroke. That leaves us ready to start another intake, another compression, power, and then exhaust. So, not many people like graphs, but to me, my favorite part of this whole project is this graph right here. All of these steps are great, but this is what's important. This is what's called a PV diagram. This black line here traces out the pressure and volume inside the cylinder of our engine as it goes through our process. As we can see, based on some other thermodynamic work, the area inside of this shape here is the actual work that we get out of our engine. And the fact that we can get all of that from just a picture, I think is pretty cool. So now, when we put those principles into practice, here we have a fuel cell that provides fuel through this tube into our carburetor, where it mixes our air-fuel mixture. Now, when we turn the engine over, So, this project idea, we were inspired by a YouTube channel by the name of Texas, where he did something very similar. In fact, the 3D model for our cylinder came from him, and we really want to give him a big thank you. As I mentioned before, this is made out of a 3D printed resin. This resin in particular doesn't deform until about 85 degrees Celsius, so we can't run it too terribly hard, but obviously it still works. We got our resin blank from China in the mail, like everything else these days. And then we took sandpaper and polishing compound to make it clear and see-through. Sadly, that's not the end of the construction story we have. So, as you might know, when metal gets hot, it expands. Our piston itself is made out of metal, so the inside of this is actually overbored by a few thousandths. That means we also had to overbore the inside of our cylinder, or else it would jam when it was first starting, and that led to some fun issues with compression. The way we solved those were by using a mix of oil treatment and 10 weight 40 oil on the inside of the cylinder itself. That helped restore our piston rings to what they should be doing.